Good afternoon, it's Chemistry B. I'm Mr. Pack, your host with the most. It is Unit 5, Equations in Stoichiometry, Day 6, endo and exothermic reactions. Thankfully, we do not have any math in this note guide, so I think you'll find it a little bit easier. So, without further ado, alright, chemical reactions will generally involve either the release or the absorption of heat. Alright, endothermic and exothermic reactions or endothermic processes. Remember, one gives off, the other one takes in. Alright, so chemical reactions will generally involve either releasing heat or the reaction absorbing heat. Alright? Now what we have to remember is two different viewpoints, which makes this a little bit tricky. You have to view things from the system. We always view things from the system, and that is what the focus is on. Okay? Everything else around it is called the surroundings. Now if you focus on the surroundings when you're talking about a reaction, it's going to be the exact opposite of what the results should be. You're always focusing on what the system is, what the focus is on. So if a reaction is taking place, it's not necessarily what the reaction, where it's taking place. For example, like in a glass beaker, it is what's going on inside that glass beaker. All right, so and everything else around that is the surrounding. So that glass beaker is the surrounding. So if the glass beaker heats up, okay, you're focused on the glass beaker, you have to focus on the system. All right? So when dealing with heat, flow is always from the system's point of view. Always from the system's point of view. All right, in an endothermic reaction, the reaction, which is the system, gains heat as the surroundings cool down. It absorbs. Okay, the surroundings absorb. The reaction, the system gains heat as the surroundings cool down. So the reaction absorbs the heat. Example on page 506. Page 506 has two examples. And one is an endothermic reaction and the other is an exothermic reaction. The endothermic reaction is the one that it shows on the left, which shows the person around a campfire warming up. Okay? The endothermic process is the campfire. Okay? The person, which is the system, gains heat from the surroundings of the fire. So if you're looking at the person being the system, all right, then it is gaining heat from the surroundings, which is the fire, and that is an endothermic reaction. The person is absorbing the heat. Now that's obvious, but if you look at it from the other point of view, if you look at it as the fire is the heat, the fire is the system, and the surroundings includes the person in the chair, then it screws you up. So you always got to focus on the system. In this case, the system is the person. All right. This endothermic reaction is defined as a positive value because the system has gained heat. So it's a positive value. In an equation, you would see it as a positive number. Okay. So let's take a look at another example of an endothermic reaction. Sunlight plus CO2 plus H2O produces C6H12O6 plus 6O2. Of course, this is our photosynthesis reaction. All right. So in an exothermic reaction, and on page 506, the exothermic reaction is picture letter B, which is the person who's running. The system is the runner, and the surroundings obviously are the air. In an exothermic reaction, it loses heat as the surroundings heat up. Okay? The reaction, which is the system, loses heat as the surroundings heat up. So this is a release. Exothermic is a release. All right? So, like I said on page 506, the body loses heat to the surroundings. This will be defined as a negative value because the system has lost heat. And an example would be quicklime, which is calcium oxygen plus H2O, produces calcium hydroxide plus the heat. Now this is a negative value. This would be a negative number over here because the system has lost the heat. So how do we recognize this? All right? How do we recognize this? Okay. Let's take a look. The system is a chemical reaction. That's what we got to focus on. The system is a chemical reaction. If heat or work is flowing out of the system, the change sign on enthalpy is negative, meaning it's an exothermic reaction. Okay? If the heat or the flow is into the system, the change on the sign on the enthalpy is positive, making it endothermic. Now remember, enthalpy is the change of heat. Okay? Enthalpy is change of heat. Out here are the surroundings. Okay? This is all out here is the surroundings. Chemical reaction is taking place inside this box. And if the chemical reaction, heat or energy flow out of the system to the surroundings, it is an exothermic reaction. And the sign in the formula would be a negative. If heat or flow is going into the reaction, means it absorbs it, then it is a positive enthalpy change, and therefore it is an endothermic reaction. Okay? So, if the reaction itself loses heat, it's exothermic. If the reaction itself, the system itself, gains or absorbs the heat, then it is a endothermic reaction. Okay? So I'm going to go back for just a minute and point out that in this equation, even though it says plus heat, we don't have a number over there. This is a exothermic reaction because heat was lost to the product. Okay? All right? So that is how we tell the difference between endo and exothermic reactions. And that is our Unit 5, Note Guides, Day 6.
In this context, there's no disrespect, so when I bust my rhyme, you break your necks. We got 5 minutes for us to